Okay, our next type of sequence is called the geometric sequence. And the explicit formula that we're going to use for this is a sub n is equal to a sub 1 times r to the n minus 1. Now in this case, r is going to stand for the common ratio. So what are we multiplying or dividing each term by to get to the next term? So whenever we use geometric sequences, we're going to have multiplication and division. Whereas when we did arithmetic sequences, we always had addition or subtraction. So let's look at this example here, 5, 15, and 45. What do we have to do to get from 5 to 15 in terms of multiplication? We're going to multiply by 3. Then the same thing is going to happen going from 15 to 45. We're going to multiply by 3. So that means that our common ratio is r equals 3. So let's go ahead and put this into the explicit formula and see if we can find the third term in this sequence. We want it to be 45. So we're going to go a sub 3 is equal to the first term, which is 5, then times the common ratio. The common ratio is 3, and then n minus 1. So n in this case is 3 because we're looking for the third term, so 3 minus 1. And then let's go ahead and simplify what we've got inside the parentheses. So 5 times 3 squared. 3 squared is 9, times 5 is 45. And you can see that this matches up. Our third term in the sequence is 45, so we know that our explicit formula does in fact work for this geometric sequence. Okay, for problem number 1, we're going to be given three different sequences, and we're being asked to determine if they are geometric sequences. So remember that what we're looking for with a geometric sequence is going to be a common ratio. Are we multiplying or dividing the first term by the same thing as we do the second term to get to the third and the fourth and so on and so on? So if we're looking for a geometric sequence, we're only looking at multiplication. So what do we multiply 3 by to get to 6? We multiply it by 2. 6 times 2 gives us 12. 12 times 2 gives us 24. 24 times 2 gives us 48. So since we arrived at the same number every single time, we have a common ratio of 2. That tells us that yes, this is a geometric sequence. Let's move on to problem number 1b. We're given 3, 6, 9, 12, and 15. Well, you should pretty easily be able to tell that we're not multiplying 3 by 2 and 6 by 2 to get to 9. What we end up with is plus 3, plus 3, plus 3, plus 3. So since we don't have multiplication or division that gets us to the next term, that automatically disqualifies it as being a geometric sequence. This is in fact an arithmetic sequence instead. Now problem number 1c, they try to get a little bit tricky on us. What we have to do is we have to go back to our rules for what do we do when we multiply bases. When we multiply bases, we add exponents. And you can see here that we've got the same base all the way through. We've got 3's all the way through there. Now the exponents go from 5 to 10 to 15 to 20. We don't need to plug into our calculator 3 to the 5th, 3 to the 10th, 3 to the 15th, and 3 to the 20th. We should be able to do this in our heads really, really easily. What do we multiply 3 to the 5th by to get to 3 to the 10th? Remember that when we multiply like bases, we add exponents. So to get from 5 to 10, you would go 3 to the 5th. To get from 3 to the 10th to 3 to the 15th, again, like bases, so we're going to multiply by 3 to the 5th. From 3 to the 15th to 3 to the 20th, again, like bases, so we would add 5 to the exponent. So again, we're going to be multiplying by 3 to the 5th. So yes, this one right here is a geometric sequence because we're multiplying by the same thing every single time. Okay, so for problem number 2, we're going to use the explicit formula for a geometric sequence to find the 10th term for the sequence 4, 12, 36. So what we're going to do is we're going to start with our explicit formula, which is a sub n equals a sub 1 times r to the n minus 1. And we're just going to start plugging in the information that we know. We know that we're looking for the 10th term, so we're going to make this a sub 10. That's equal to the first term, 4, times the common ratio. So now we need to find the common ratio for this. Now remember that this is a geometric sequence. We're being told that. So how do we get from 4 to 12 by multiplication? It's 3. So we know that r is equal to 3. So we're going to plug that in there. And then we also know that we're looking for the 10th term, so we're going to go 10 minus 1. So go ahead and simplify this as much as you possibly can. 4 times 3 to the 9th. And then you're going to need a calculator for this. It turns out that the answer is going to be 78,732. You would not be expected to do math like this in your head or just on paper. You would either be given a calculator or you're just going to be working with smaller numbers when you get to your quiz or your test. Now in problem number 2b, we're given that the first term in the sequence is 2 and the fourth term in the sequence is negative 54, but we don't have either the second or the third terms. So rather than trying to guess and check, we're just going to go ahead and use the explicit formula to figure this out for ourselves. So we know that we've got the fourth term here. So a sub 4 is equal to a sub 1, which is 2, times r to the 4 minus 1. Okay? Now what we're going to do next is, notice that we've still got two variables here. We've got an a and we've got an r. But we do know what a sub 4 is. A sub 4 is negative 54, so we can go ahead and we can change that. And we can say we've got negative 54 is equal to 2 times r to the third. So now we've got enough information. We only have one variable now that we're looking for. That means we can solve for it. So go ahead and divide out the 2, and we get negative 27 is equal to r cubed. Now, all we've got to do is to isolate r is to take the cubed root. So the cubed root of both sides is going to give us now negative 3 is equal to r. So that is going to be our common ratio, negative 3. Now to be able to find this one here, all we have to do is go up 2 times negative 3 is going to give us negative 6. Negative 6 times negative 3 is going to give us 18. And then just to check to make sure that we've got this right, 18 times negative 3 is negative 54. So we do have the correct common ratio and we do have the correct sequence. For the last problem in this section, we're going to look at a concept called the geometric mean. Now, the geometric mean is actually a fairly easy thing to find. It's just going to be the square root of x and y, where x and y are just two numbers. Now, one thing that you need to know about the geometric mean is that the answer is always going to be positive. Remember that when we take the square root of a number, say the square root of 4, the answer could be plus or minus 2. But when we're talking about geometric mean, we're only ever going to be talking about a positive number. Okay? So if we're given 3 and 12, and we're asked to find the geometric mean of that, all we're going to do is just plug those numbers in to a square root. So 3 times 12 is the square root of 36, and so you get the answer of 6. So when we go over to problem number 48, we're asked to find what is the geometric mean of 48 and 3, or what is the missing value between 48 and 3 if this is a geometric sequence. So all we're going to do is go square root of 48 times 3. 48 times 3 is the square root of 144, and so you get plus or minus 12, but since we're only looking for a positive solution here, we're going to get just 12. Now remember that the reason why it's going to be positive is, let's say that we had negative 3 and negative 12 instead of, say, 3 and 12 there. If we had negative 3 and negative 12, then the only way that we can get from this negative 3 to a negative 12 is to multiply the negative 3 by a positive number. So negative 3 times negative 2 gives you 6. 6 times negative 2 then gives you negative 12. So this middle number right here in the sequence, so we've got 3, 6, and 12. If negative 3, or if 3 and 12 are negative, you have to have a positive number in between them because you're looking at a common difference of negative 2.